So I actually spent maybe a good half hour this morning doing this incredibly mindless task of untangling a giant box of old USB and HDMI cables.
Oh no, the dreaded cable drawer.
Right. And my eyes are just glazing over. And I'm sitting there thinking, man, I really wish a robot could just do this for me.
Oh, absolutely. Just hand the whole mess off.
Yeah. And that exact frustration is, well, it's really the core of today's deep dive, because we're looking at Nobel laureate Demis Hassabis and his very optimistic vision for the immediate future of science.
It is a fascinating vision. He basically sees AI not as a replacement for scientists, but as this ultimate lever.
Which is such a refreshing take. And speaking of, having AI do the heavy lifting, this podcast is actually sponsored by Embersilk.
Yeah, they are fantastic for this exact kind of thing.
You really are. If you need help with AI training or automation or integration or software development, they help uncover where agents can make the most impact for your business or even your personal life. Just check out embersilk.com for all your AI needs.
So to understand the sheer scale of the friction that Hassabis is trying to remove, we really have to start with AlphaFold.
Right, because predicting the 3D structures of 200 million proteins is just...
It's essentially every single protein known to science, which is what won him the Nobel Prize.
It's basically like someone suddenly handed us the full instruction manual for every single Lego piece in the human body.
That is a brilliant way to put it, because historically, determining just one single protein structure using X-ray crystallography, that could consume literally years of a researcher's life.
Wait, years for just one?
Yes, years. And AlphaFold totally bypassed all of that physical lab work by using deep learning to map the sequences directly to their spatial shapes. Hassabis calls it science at digital speed.
Which makes sense, because an average protein now folds computationally in, a few seconds?
Exactly, seconds. And more importantly, that data was instantly made available to over 3 million researchers globally.
Oh, wow. So it completely democratizes discovery.
Right. It completely strips away the need for, massive elite lab funding just to access the foundational maps of biology.
But wait, if we run with that logic, doesn't it fundamentally change the day-to-day reality of the scientist?
How do you mean?
Well, there's this argument in the scientific community that doing the physical wet lab work, like the tactile repetitive tasks, is exactly what allows the brain to subconsciously process complex problems. You're pipetting liquids, your mind wanders, and boom, the aha moment strikes.
There's definitely a certain romance to that idea. But fellow Nobel laureate Paul Nurse offers a much more grounded reality in our sources.
Okay, what does he say?
He points out that the vast majority of real wet lab work is quite literally just moving the tiny amounts of liquid from one little tube to another.
So highly repetitive, kind of like my cables.
Very much like your cables. Nurse argues that the real joy and progress of science lies in systemic, creative thinking.
I see. So offloading the boring pipetting to robotics and the data crunching to AI doesn't rob the scientists of their intuition.
Not at all. It actually frees their cognitive load so they can tackle exponentially larger, far more complex systems.
Which brings us to that ultimate ambitious project, the virtual cell.
Yes.
The goal of simulating a completely functioning biological cell. I imagine traditional math really struggles with that, because biology isn't just a neat, predictable physics equation.
Exactly. Nurse perfectly describes biology as floppy and sloppy.
Sloppy and sloppy.
Yeah, it's chaotic combinatorial data. A traditional mathematical model simply can't map that level of noise. But AI doesn't need a neat equation.
Right, because it's uniquely suited to ingest all that messy reality and find the hidden statistical patterns underneath.
Precisely. And by letting AI map the noise, human researchers can step back and become architects. They get to focus on the big questions of how life actually operates as a whole system.
And that architectural freedom is exactly why Hassabis believes we are entering a brand new 10 to 20-year golden age of scientific discovery.
It's just an incredibly inspiring paradigm shift.
It really is. And for you listening, it means the bottleneck is no longer data generation, it's just your imagination.
Yeah.
You won't need a multi-million-dollar facility to make a breakthrough anymore. Multidisciplinary science becomes incredibly accessible when the heavy lifting is handled digitally.
Absolutely. And it leaves us with this thrilling final thought.
What's that?
Well, if AI acts as the ultimate tool to uncover the laws of nature, how is human curiosity itself going to evolve? Will we just stop spending our careers asking what a structure is and begin asking entirely new types of questions we couldn't even fathom before?
Oh, I love that. We are effectively unchaining the human mind to do what it does best. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.